Lab 4, Oscillations by Sherwin Praveen. The purpose of this lab is to understand and predict the motion of a spring with a two-dimensional model. We find that by writing some code, we can accurately predict the motion. After tracking the motion, we find that by using the initial conditions, we can predict the motion of our ball. We also learned that we can find the energy changes during the motion. Main ideas and principles. We use the energy principle, we use all our update formulas, and we use the total energy formula. We use the energy principle to show how energy cannot be created or destroyed, but just transferred. We use our update formulas to calculate the updated velocities and positions throughout the motion. We use the total energy formula to show the change in energy from the initial conditions to final conditions. Initially, the ball is placed from rest a little distance above and to the left of the equilibrium position. The system we choose is the ball, the spring, and the earth. We do this to show that the change in energy is zero and energy is transferred from potential to kinetic energy. We started with tracker and plotted the position of the ball throughout the motion. We then created a model using GlowScript and inputted our initial conditions. We finally inserted our experiment data to compare with our model. Our coding details. After inputting our initial conditions, we added our distances to add to our potential energy of our spring and our forces. We then created formulas for our update formulas and our energy formulas. We finally created a formula to measure the change in energy throughout the motion. Similarities and differences. As we can see, our model is very accurate in predicting the motion of the ball, even with two dimensions. We can see a little bit of discrepancy from the model, but not too much. As noted in the previous slide, the model isn't entirely perfect in replicating the experiment. This could come from real-world aspects, like air resistance or the ability to perfectly map out every position on tracker. For your model system, is the energy principle satisfied? Justify your answer by discussing briefly your plots of energy changes. Looking at our model, we can clearly see that the energy principle is satisfied. When we set our surroundings to be nothing, we should have gotten our change in energy to be zero throughout. Based on the graph, we can see that our delta E was zero throughout the entire motion. Conclusion. Our results show that a model can be used to well predict 2D motion. This lab also proves that the energy principle will always hold true, that energy cannot be created or destroyed. Thank you.